Yeah, distraction is easy for me right now because as I mentioned in Discord, I got to sleep at around 4 a.m. partially because my blankets were messed up because my cat decided to have a nice big hairball on my comforter, which meant that I was cold for a lot of the night. Uh, yeah, that was fun. It's pretty cold out today. Hope everybody's staying warm. Okay, so let's see. Um, so modules, right. So with regards to the quizzes, I went ahead and activated this quiz. I will be sure to activate these quizzes later. I just want to make sure that they have no errors and stuff like that. First quiz, you've got unlimited tries. Don't worry about it. So the only thing is that there's a 15-minute cooldown period between attempts. So if you get something wrong, you'll have to wait 15 minutes. So that's fine. I adjusted the due date for Fox and Rabbit. Please be aware that you should be watching the module videos, and I have the canvas automatically migrated these due dates. So let's see what February 3rd is. February 3rd is next Wednesday, which seems perfectly appropriate for the Arraylist homework. You know, this semester is off to a weird start because of that I don't know if the next set of quizzes will have unlimited, but I will make sure that it can take the highest and there will be multiple attempts because there's always the possibility of technical difficulties, but there should be a generous amount of tries. The quizzes are meant to be low stakes, low stress. Good ways of checking, because in the past, what I've done with quizzes is that I use them as partially an attendance kind of deal. But I always also let students make it up if they, came by to office hours and made it up that way. So, it's not really something that I'm too strict about. Again, the quizzes are supposed to be low stakes and low stress here. Okay. So, with regards to the Fox and Rabbit, hopefully you've gotten to a point where you are able to, where you're doing better. Is anybody like really stuck in Fox and Rabbit? Okay. Because if you are and you're struggling, let me just kind of show you what I've been doing for my algorithm and the way I've kind of set it up. So the solution I have is very, very simple, right, for Fox and Rabbit, which is that if you look for the fox, right, you can, right, my idea is that I'm going to stay still, right? Think about the way prey works in real life for a second. Prey is, they basically graze and they graze in a solitary location until they have to move for food. We don't have to worry about that, but essentially they're pretty solitary unless they see a predator, in which case they bolt. Okay, so whereas predators, right, they do the whole stalking thing. So the fox has some stalking code, which is this batch. But so what's the stay and what's the equivalent, which is just graze? That's staying put. So what about for like bolting? Well, that's all we have to do for that one, which is that essentially get out of line of sight. So the easiest way to get out of line of sight for a rabbit is to just, right, look for the fox. And if you see the fox, move out of its line of sight. So if can move, so if I can move in high 80s is a good percentage with something very simple. So if what I'm going to show you should get you into the high 80s. If you want to expand on. So first off, if can move model.turn I4, and yes, if you're making a ton of hand gestures while coding, that's perfectly appropriate for this assignment and expected. So right, this is the fox. So I is in this direction. Okay. direction I'm pointing in front of you. Okay. And then, well, sorry, relative to me, fox is that way. So model.turn I4, that would be that way, right? It's the direct opposite, right? It is the number of 45-degree turns, which for me, well, I'm going to try to mirror it to your side, which is 1, 2, 3. Let's see, is it mirrored? No, sorry. 1, 2, 3, 4. So 4 turns that way. That's directly away from the fox, but that's actually a pretty. But this doing it like this is actually pretty terrible, and not good for my survival. Specifically, if I do this. Okay, why does this strategy, for want of a better word, suck?
You're not moving out of their line of sight. You're
exactly right. I'm moving away from the fox, which is great, but I'm not shaking him. So right, and if we run greater, we're going to see, of course, that we don't really do any better than random, because as soon as unless the fox sees us near the end of his thing, we don't really escape. Unless he sees us at the end of the time limit, we don't escape, which is not great. Okay, so maybe now, mind you, but I do want to get away from the fox, but I also want to get out of line of sight, which means he's got this line of sight, but he's seeing this way, and this way, which means there's this like entire cone here and here, right? He's got these big cones. So if I'm here, I can just kind of sidestep, or I can step back and away because I like being back and away. So now, so we can step back into the left or back into the right. Now, part of the reason you might be having trouble getting into high numbers is, believe it or not, it does matter which one you do first. The fox has a bias in its code as to which way it wanders and which way it tries to go. So you'll just have to experiment. You will just have to experiment and see which one. But look, just simply doing this, if I can move out of the line of sight, I do so. Back into this is essentially back into the left, right? Now let's try back into the right. Okay, that is better than doing nothing, but that is worse, right? That is worse. We were getting 35 by trying left, and then we were getting 35 by 18 we were getting half the survival rate by doing right. So maybe make some multiple if statements, and you might want to try. Okay, you need to experiment for getting out of line of sight. What works best versus what, so because there's different ways you can approach this, but generally just doing this gets you a pretty decent survival rate. Again, 35% survival rate. That's a 60 out of 100 right there for the code grade with just this code over here. Just a simple strategy. So chaining a bunch of if statements, or simply putting a bunch of if statements together, essentially else ifs, but you don't need to throw the else if in because you're returning in here, and just stacking them in this for loop, an if statement works pretty darn well. Now, for those of you, so this is a good basis. However, it will not get you to like the 99% survival rate just doing this alone, right? To get like into the mid high 90s, you need to take into account. Notice I have a lack of variables here. It's only when you have to, those kind of things are to get mid and high 90s. That's when you need variables such as, have I seen the fox recently? If I haven't seen the fox recently, well, maybe I check how far away I am from the walls. And if I'm too close to the walls, maybe move closer to the center so I have more space to move around. Once you've got the fox, so long as once the fox is looking at you for you, as long as you're not caged in, you're probably going to be able to avoid it pretty well. That being said, getting 100% survival rate is kind of difficult because luck is involved. Now, also, since the second week and so on is very how to say, it's not the, this is when you've got some time to where you are starting to get to work, but you aren't like overwhelmed and swamped with work yet. I should point out that I have an extra credit right over here. Okay, why not take the time to teach yourself regex? If you've taken my 1051 course, this is basically something you've already done in that, but you're still eligible to do that. For those of you who haven't taken my 1051 course, regular expressions will take you about maybe 2 to 3 hours to learn, but will basically save you maybe 20 hours over the course of not this semester, but at least through your degree, because regular expressions are super useful, and they're built into a lot of different, they're built into things like Microsoft Word. They're basically a language for searching for things, for strings of text. It's very, very, very powerful. But this is it has no due date, so get it done to me at the end of the semester. That's perfectly fine. You can complete it in any language you want. So if you're more comfortable in a different programming language, you can do it in a different programming language. Here's the PDF. It's got some questions, which is basically looking for, so if you've done, so this is like the first half of the assignment I give for 1051 students when they're working on regular expressions. So basically figure out do more words end in ION or ING? How many words contain a Q that are not followed by a U? How many words have no vowels? For that, we will use the dictionary, this dictionary file, which has every word in the dictionary in it. Y is not a vowel. No, it is not a vowel for the context of this. A-E-I-O-U. It does have every word in the dictionary, including the insults and things that your mother or grandmother might be upset at you saying. Well, I don't know your grandmother. Maybe they wouldn't be upset with you saying some words. But anyway, so point being is that don't freak out if you see that, or if you're running it around somebody who might have that issue. Again, it's a dictionary file. This is what is a dictionary file? It's a file that's located on a lot of computers, specifically it's specifically the file that your computer will be using for doing spell checking and that kind of thing. So we'll talk more about the issues with dictionary files and spell checking and stuff when we talk about hash tables and this and the Scunthorpe problem. Okay. Now, for those of you who are also like looking ahead and stuff and trying to get a head start on the modules, for when we get to linked lists, which is typically the area where the work where I think it's the most difficult assignment we have, mainly because of your experience at that point, as well as the, you're trying to get ready for exams in other classes. I'm going to have actually 2 assignments. You get to choose one. So I'll have an easier assignment, and then the solitaire encryption is for if you really want a challenge. So if you're trying to get ahead, just be aware of that, okay? So, and part of this is because I realized it was kind of just a lot of work for some students to do this in the more in the online environment. All right. Any questions about Fox and Rabbit before I just talk a bit about the new homework, and then I'll meet with students to either, to my primary aim is to help students, and then I'll take demos. Okay. So any questions about Fox and Rabbit before we move on? All right. So with regards to your Arraylist Exercises assignment, this one is unfortunately a boring homework, which I have sometimes. Wrote this back in 2018. You definitely want to do this because we're going to be going over Big O next week, and your answers for this will be used for the Big O assignment, or for a small part of the Big O assignment. So just be aware that what you do here will impact that somewhat. So we'll be dealing with generics. Please watch the videos on generics. And note that basically your grade does revolve around using 5 points each for each method for using generics correctly. Okay. Now we have 6, let's see, yes, 6 problems here. Problem 5, I want you to try, it's not problem 5, problem 4, 2.4 is permutation. That one's actually a very tricky one. I want you to try it yourself, but we will be going over it together before the due date. So if you get stuck on that one, if you find yourself banging your head on this one, then don't worry. We will go ahead and do this one in class, but the other ones you will definitely want to do. When you're testing your code for 2.6, it is very, very, very important that you test it on the examples I give, which is that the input is 1456552, and I want you to remove all 5s from that list. Very important that you try that. Because if you don't try that one, you might find that your code doesn't work when you come to demo it. Because this example catches a very common edge case. Okay, so when you demo, you're going to be wanting to explain how you did remove all instances, and then we're going to just pick one that we're going to look at your code and pick and ask you to explain another function that looks interesting. A lot of these I can just tell if they're correct by kind of glancing at them, because they're fair. Some of these, like uniqueness and all multiples, are fairly straightforward. So any questions on this one? Any questions about generics? So generics and abstract classes have almost nothing to do with each other, unfortunately. So what is an abstract? Interfaces and generics also have almost nothing to do with each other. So an interface is essentially a blueprint for a class. No interfaces in abstract class? Well, interfaces, an abstract class is a halfway point between an interface and a class. Okay, an interface is this concept in object-oriented programming. It's the idea of like, okay, take the lists that we're going to be learning. We have different ways of writing a list, 2 primarily different ways of writing a list in Java. Well, in other programming languages too, but in Java, we basically say we have 2 different types of lists. We've got our array lists and we've got our linked lists. Ostensibly, there could be other ways to write a list, but in Java, an interface simply says these are the requirements you need to fulfill if you want to be considered a list. Or in the case of sets, an interface for a set would basically say, okay, these are the requirements you have to fulfill for Java to consider you a member of this class, to be a descendant of this class. So what an interface does is that it provides a name of a bunch of functions and what they should take in and what they should return, but nothing else. It's basically that annoying phrase in interfaces, that annoying phrase in math textbooks. The rest is left as an exercise to the user. Okay. Interfaces are useful though, because you can implement multiple interfaces. You can only extend one class, but you can implement multiple interfaces. Did you watch my videos on on an interface or no? Okay. So, all right. So an interface basically says, if I were to create, let's say, a new project, next, enter examp. Okay, and we'll open it in this window, right? So let's go ahead and create a new Java class interface. And let's call it we could call it student. Let's see. Just trying to think of a good example for this one. Oh. Okay, so you're confused about interfaces and how it differs from how abstract classes differ from an interface. Okay. Abstract classes are kind of the halfway point between a interface and a class. An abstract class has some methods in it, which are completely filled out just like a normal class would be. Okay? But it's also the halfway point for an abstract class is that there are some methods that are labeled abstract, which are that annoying to be, to be entered in by the user, right? Or to be entered in by whoever extends the class. Okay? Does that make sense? So let's go ahead and create a, let's see. Did that answer your question or no? So, okay. Okay, so hopefully that's good. So if we look at the abstract list class, we can, what the entire idea here is that it's got some methods over here that will have automatically been created to because they're going to work regardless of the way that a class is going to work. Such as, yeah, to implement an unmodifiable, the program only needs to extend this class and provide modifications for the get and size methods. So basically, this class is a list, but it doesn't know how to get things out of it, and it doesn't know how to tell how big it is. So that's left up to how you want to make it, and then it just depends. Direct known subclasses, Arraylist, and the Arraylist does do that. So we will rarely use abstract classes, but we will be using generics quite a bit in this class. In fact, we rarely use interfaces. Yeah, that's exactly the way it is. An abstract class is kind of like an interface, but with some of the methods filled out. That is an answer that I would accept on an exam if my question was, what is an abstract class? Why would you use one versus the others? Object-oriented programming is weird, man. You would use an interface it's all about control, and specifically if you want things to be done a certain way or not. Okay. Now, with generics, let's go ahead and just talk about that for a second. I'm just going to create an example class here, since this is the interesting part. Do I need to make my font bigger, or is this good for everybody? Public static. Let's go ahead and I'm going to write an integer, some public static int sum list. And this is a pretty straightforward example of a way we can work with generics. Sum list. Now, list is the parent interface or parent class for Arraylist, so it's perfectly fine for me to write list instead of Arraylist because it's shorter. Now, and all this it's going to do is says, given a list of integers, that's the way to read this. A list of integers, okay? Then return the sum. That's all it is. That's all this does. And generics make that easy. So for I, so I'm going to just simply do for I, boom, boom, boom. For, oh, actually, even easier. I'm going to use a for each loop. For int I in list int sum is equal to 0. Now remember, even though it's an array list of integers, I can go through it pretty straightforward. I can go through it like this and simply say int I because it automatically will convert between ints and integers. Okay, wrapper classes are useful like that. And if you don't know what that is, all this is the class version of a primitive, right? Sometimes you need a class sometimes you need to use a primitive, but you can only use a class. Weird times when that happens, primarily with generics. So Java provides a class version of every single primitive. So, and it will automatically convert between them. So all this is sum plus equals I, return sum. Very, very easy to do. It just given a list of integers, sums it up. Very straightforward. However, without generics, without basically defining that, restricting what could go in. So here, I'm going to write this sum list. No, I'm going to call it raw because that's what happens if you don't, that's how it refers if you don't use that. First off, I'll start getting a warning. Actually, I'm going to just try to do this. And you'll notice that I'm going to get an error or a warning at least. It says, okay, what is the issue that we have here? It says, hey, it's a object. This is a list of objects. You're getting an int out of it. When you work with lists and you don't use a generic, it has no idea what you put into the list. It could be an integer, it could be a string, could be whatever. So it's asking for so it says, okay, we're just making a list of objects, which could be anything. I go into pretty good detail about this in the videos. So, okay, I'll just simply say object O for every object O in the list. And then since those should be integers, I'll just simply say integer I is equal to, and then I do this annoying thing called casting over here to say, Java, trust me, it's an integer.
Can you cast it in the for each loop?
What? Could I cast it in? Maybe. I'm actually not sure about that. But this is the way that I've always done it, and it would probably look messier if I did cast it in the for each loop. But notice that it's just that if I like pass this, so PSVM, I'm going to create a list of integer array list over here is equal to, sorry, I'm going to call it list new array list. Yeah, this has turned into a bit of a lecture. Sorry. You can just do, I always initialize my lists like this.
Okay, I feel like it just gets a bit tedious when you're adding like a lot of.
Yeah, it does. But but when you're learning how to do lists, it's perfectly fine. Now, arrays as list, by the way, as mentioned in chat, just simply takes an array and converts it into a list, which can be useful. So all I'm going to do over here, though, is just do for boom, boom, boom. I'll just add 400 items to the list and just simply say list.add I. Okay, and we can pass that directly into the first one. Okay, but say I was just doing a list of just, anything, and I did this, and then I forgot what I was doing and simply said list.add foobar. So first off, I can't pass this into because this is no longer an array list of integers, sum list, because this is no longer a list of integers, it's going to give me a very big flag. But if I try to run this, it will kind of just blow up in multiple ways. It will first tell me, hey, you can't take a string and cast it into an integer. And then if I try to do that over in SumList raw, again, it's just going to blow up because I have this random string that I just added in here. So list, I'm not really sure what you mean. List integer functions as a pointer, even though it's an interface. It's like it's all about that polymorphism. It's all about that polymorphism. This is definitely a reference. The way Java always works for anything that is not a the way Java works for anything that is not a primitive is that whenever you have this assignment statement, the memory location on the right is stored in the variable on the left. That's the way. That is, like, for week 4, that is essential to understand for week 4. The way it always works is that the memory location on the right gets stored in the variable on the left. That's all. So yeah, it's always a pointer. Unless it's a primitive, it's always a pointer. The fact that it's an interface has nothing to do with it. This is just simply saying it's a list that we can. There's really, when you're coding like this, there's really no difference between a list and a class because of the polymorphism. The idea that we can, and inheritance. We can use the upper class, the class, that the thing that's higher on the hierarchy, the more general type, in our functions in our code, and you'll see me doing that a lot. So with regards to our list function, again, I go into the detail on this in our videos. If you have more questions, I'll be happy to answer them. Because I want to give you time to ask questions about the assignments. But I go into very specific about how we use the E over here, which is very important to use. Okay. So with that, I'm going to go ahead and split us into breakout rooms. I'm going to let you choose your own room. If this feels a bit overwhelming, generics look harder, way harder than they actually are. Generics make your life a lot easier because they prevent you from shooting yourself in the foot. Okay. So I've got some very big rooms, but that's okay. Actually, let me go ahead and see what I can do here. Can I create more rooms from here? Because I thought I could. Okay, stop.